Welcome back. So, we've established that the latency is unacceptable and noticeable when recording MIDI from this Alesis Nitro Mesh eDrum kit. I think that's what it's called. Sorry if the name's wrong. We've established that the latency is unacceptable when we're monitoring the triggered audio of the Superior Drummer VSTI. Part two, now we're going to test monitoring the audio of the drum brain. You can see there's a new cable now. So I'm taking the audio out and going into my interface and mixing that with the project, and I'll be hearing the audio from the drum brain and the audio from the project. So I'm monitoring the eDrum audio instead of the triggered audio from Superior Drummer. In theory, this shouldn't, if my understanding is correct, this shouldn't really change the latency of the triggered MIDI. Because all that's really changing here is what I'm listening to in my headset, which shouldn't change. It will change my playing, but we're taking measurements of the playing with a mic versus when the triggered MIDI gets recorded in my DAW. So in theory, I don't actually expect any change, but the only relevant change, I believe, for when the MIDI registers in the DAW, when it gets recorded in the DAW, the only relevant change will be that we'll be completely disabling the Superior Drummer VSTI during tracking. So, hypothesis, maybe that has an effect. I certainly enjoy it an incredible amount more just monitoring the audio from the drum brain box. I haven't done that since I first got this kit like 3-4 years ago or something. And holy crap, it's so much noticeably better than monitoring the Superior Drummer samples. Geez, I could do it for hours. I'm so glad that I tried this. But yeah, so let's get rolling. I'll get everything set up. I'll be recording the MIDI with the Superior Drummer VSTI disabled. I'll simultaneously be recording the audio of me smacking the pads through this large diaphragm condenser. We will measure the latency and see if it's any better than part one. Yeah, see ya in Reaper.
Okay, so I have captured the MIDI. I've simultaneously captured the audio from the large diaphragm condenser mic. The state of this project is identical to when I was recording, so you can see that I've disabled the Superior Drummer VSTI. It's enabled if we dive within, but it's disabled at this level. So the theory, it was certainly more pleasant to play, to track these drums. The theory is somehow, magically, in ways that I do not yet understand, this improved the latency of the mic from when I actually played the drum, which is the mic feed signal, versus the MIDI that the DAW recorded. So, having learned some lessons from last time, and having hopefully fixed the nasty mic clipping issues from last time as well, let's zoom in here. I did not render the MIDI to audio. I think we've already proven beyond reasonable doubt that that doesn't matter. So here's our mic feed and our drum MIDI. Moment of truth. I'm finding out at the same time as you what these results will be. Oops, I forgot to make all of these MIDI notes and quantize them in length so that they actually have some thickness. So I'll do that. There we go. So now our MIDI notes actually have thickness. Let's see what's going on. Not looking good, guys. Not looking good. Okay. Yep. 8 milliseconds. That was, so last time our first sample was at 7 milliseconds. I'm going to write these down as we go this time. So, all right, so our first data point is 8 milliseconds. And we'll just, let's do 4 data points. Let's do, wait, how many did we have last time? 1, 2, 3, 4, we had 5. So let's do 5 very evenly spread data points. 2 towards the beginning, 1 in the middle, 2 towards the end. So there's 1, about right here. Take another measurement. Okay. All right, there's the beginning. And there's where the MIDI was registered and recorded by the DAW. And this selection is 0.06, or 0.006, 6 milliseconds, in other words. So there's 2 samples. So this is still, so far, these 2 samples are consistent and low variance with the measurements we made in part 1, which is starting to chip away at the theory that this latency is project dependent. I think, now that I think about it, I think I'm going to do a part 3 as well, where I add a bunch of tracks with like real audio playing through them and like a bunch of high latency plugins, or not an absurd amount, but like a reasonable amount. Let's say I'll add 3 additional tracks with like, I'm not even sure what are some good representative examples of high latency plugins. Maybe like Soothe, or like FabFilter's Pro L2. We'll give it a shot. It's worth a. Maybe I should make it somewhat extreme just to see if the composition of the project, the state of the project, what plugins exist, actually affects this or not. So far, this seems quite consistent with our previous readings. So we need to change some other variables. Okay, so there's measurement 2 done. Now we need to take a measurement smack dab in the middle here, which is like there. And here's where we start registering some audio. That's weird. There's like a long ripple there. We'll go with this. And here is the start of our recorded MIDI. Okay, this is also 8 milliseconds. Interesting. This latency is higher? So interesting. So interesting. I wonder if it's dependent on what else is going on in terms of motherboard activity with your machine. I don't know. We'll keep going down this rabbit hole until we get to the bottom of it. Okay, so 3, now we go here. Let's take our fourth measurement for science. Okay. There's the start of our audio waveform and the start of our recorded MIDI, 4 milliseconds. Okay. We're improving 4 milliseconds, and our 5th measurement will be, let's go ahead and do the final hit here. We'll call this good. I'm learning that I don't actually have to zoom in enough because the resolution of 1 millisecond is significantly higher than the resolution of 1 sample. So 8 milliseconds again. Oh my goodness. So our average is considerably higher than last time, actually. So let's just get the actual average real quick. Last time our average was about like 5.6, I believe. It was around 5.6. It's within the margin of error of this experiment. 8 plus 6 plus 8 plus 4 plus 8 equals divided by 5. Yeah. So now our average is 6.8. The average of 6.8 and 5.6 is 6.2. So I may I think what I'm going to do is after part 3, where we perform another experiment to see if this latency is dependent on the composition of the project. Hopefully it's not. Hopefully this is just dependent on my system, and I'll just write a little script that will immediately, that's easy. It's easy to change the nudge amount, right? In case I change systems, I get a new computer, I do these measurements all over again, and I still want to record eDrums, nudge them after recording. I'll write a little script to nudge the MIDI by a configurable amount, an easily configurable amount. Lesson learned so far, though, between parts 1 and 2 is that you're going to want to monitor the audio from your eDrum brain. You are not going to want to monitor the audio through your drum VSTI. That is, I really, I can't exaggerate how noticeable the difference is. Playing the samples through the drum brain is just so snappy and immediate. It literally feels indistinguishable to me. I'm not a drummer. I'm by no means experienced with acoustic kits, but it feels, the times that I have played an acoustic kit, it feels it feels indistinguishable to me. But it is very noticeable. It's quite noticeable to me, even an amateur. The difference between an acoustic kit and just monitoring the triggers through the Superior Drummer VSDI, super freaking noticeable. So lesson learned there. Part 3, let's add a bunch of tracks with a bunch of latency introducing plugins and see if that has any effect on our latency between smacking the pad and recording the MIDI.
And that's going to do it for part 2. Stay tuned for part 3. Thanks for watching. Subscribe for more things. Bye.